This is 1 hour of facts about volcanoes in a soothing voice that studies have scientifically proven to put you to sleep faster because it makes you feel safer and more relaxed. Let's jump into it after you hit like and subscribe so you and others see these videos again. It really helps. Let me know what topic I should put you to sleep with next time. All right, relax and take a deep breath. Volcanoes are fascinating geological formations that have shaped our planet's landscape for millions of years. One lesser-known fact is that they can create their own weather systems. When a volcano erupts, it spews ash and gas into the atmosphere, which can lead to the formation of thunderstorms. These volcanic thunderstorms occur when the ash cloud rises high enough to cool and condense water vapor, creating lightning and even rain. This phenomenon was observed during the eruption of Mount Pinatubo in the Philippines in 1991. Where volcanic lightning was captured on camera, showcasing the raw power of nature. Another intriguing aspect of volcanoes is their ability to give birth to new islands. In 1963, a volcanic eruption off the coast of Iceland led to the creation of the island of Surtsey. Over the course of 4 years, the continuous eruptions built up the island to the point where it finally breached the water's surface. Today, Surtsey remains one of the youngest islands on Earth and serves as a natural laboratory for scientists to study ecological succession. The island is off limits to the general public to preserve its pristine condition, but researchers have made incredible discoveries about how life colonizes new land. The supervolcano beneath Yellowstone National Park in the United States is often a topic of concern due to its potential for a catastrophic eruption. Unlike typical volcanoes, a supervolcano can produce an eruption with ejecta volume greater than 1,000 cubic kilometers. The last eruption of the Yellowstone supervolcano occurred approximately 640,000 years ago, leaving behind the massive Yellowstone caldera. This eruption was thousands of times more powerful than the Mount St. Helens eruption in 1980. If such an eruption were to happen today, it would have severe global consequences, including drastic climate changes and widespread destruction. In contrast to explosive eruptions, some volcanoes produce lava flows that are relatively slow-moving but can cover large areas over time. The Kilauea volcano in Hawaii is an example of this type of activity. Kilauea has been erupting almost continuously since 1983, creating extensive lava fields. The lava moves slowly enough that it's usually possible for people to evacuate safely, but it can still cause significant damage to property and infrastructure. The lava flows have added over 130 acres of new land to the island of Hawaii, demonstrating how volcanic activity can reshape landscapes over decades. One of the deadliest volcanic eruptions in recorded history occurred in 1883 when Krakatoa erupted in Indonesia. The eruption was so powerful that it caused the volcanic island to collapse into the ocean, generating massive tsunamis that affected coastlines around the world. The explosion was heard as far away as Australia and the island of Rodrigues near Mauritius, roughly 3,000 miles away. The eruption released an estimated 25 cubic kilometers of rock, ash, and pumice into the atmosphere, leading to dramatic sunsets and climate anomalies for several years afterward. Volcanoes also play a crucial role in the carbon cycle, acting as both sources and sinks for carbon dioxide. Degassing from volcanic eruptions releases carbon dioxide into the atmosphere, which can contribute to greenhouse effects and long-term climate change. However, volcanic rocks, especially basalt, can also capture and store carbon dioxide through a process known as carbonation. In this natural process, carbon dioxide reacts with minerals in the rock to form stable carbonate compounds, effectively removing the gas from the atmosphere. This dual role makes volcanoes significant players in the Earth's long-term climate system. The Ring of Fire is an area around the edges of the Pacific Ocean where a large number of earthquakes and volcanic eruptions occur. This region is home to about 75% of the world's active and dormant volcanoes. The Ring of Fire is a direct result of plate tectonics and the movement of lithospheric plates. Countries that lie along this ring, such as Japan, Indonesia, and Chile, frequently experience volcanic activity. Scientists closely monitor volcanic movements in these regions to provide early warnings and mitigate the potential impact on human populations. Some volcanoes are located underwater and can remain hidden from view. These submarine volcanoes are just as important as their land counterparts. An example is the Loihi Seamount, an underwater volcano located off the southern coast of Hawaii. Loihi is actively growing, and if it continues to erupt, it will eventually become another island in the Hawaiian chain. The underwater eruptions contribute to the unique topography of the ocean floor and provide nutrient-rich environments that support diverse marine life. Exploring these underwater features requires specialized technology like remote-operated vehicles and submersibles. Volcanic eruptions can have profound effects on global climate. One of the most notable examples is the eruption of Mount Tambora in Indonesia in 1815. This eruption was the most powerful in recorded history and released vast amounts of volcanic ash and sulfur dioxide into the stratosphere. The particles and gases reflected sunlight away from Earth, leading to a significant drop in temperatures worldwide. The year following the eruption became known as the year without a summer, as snow fell in June in the northern hemisphere and widespread crop failures led to food shortages and famine. Volcanoes can also influence human culture and history in surprising ways. The eruption of Mount Vesuvius in 79 AD is a well-known example that resulted in the destruction of the Roman cities of Pompeii and Herculaneum. The cities were buried under a thick layer of volcanic ash, which preserved buildings, artifacts, and even the remains of people in remarkable detail. These preserved sites provide invaluable insights into ancient Roman life. The disaster also had a lasting impact on Roman society and literature, inspiring works of art and historical accounts that resonate to this day. Volcanoes are not only destructive but also creative forces that contribute to the formation of valuable mineral deposits. When volcanic activity occurs, it can concentrate minerals like gold, silver, and copper, making them easier to extract. For instance, the mineral-rich deposits found at the Grasberg mine in Indonesia are the result of ancient volcanic activity. This mine is one of the largest sources of gold and copper in the world. The geothermal heat associated with volcanic areas also has practical applications, providing a source of renewable energy in the form of geothermal power, which can be harnessed for electricity and heating. Some volcanoes have unique features that make them stand out from the rest. Old Donyo Lengai in Tanzania is one such example. It is known as the only volcano that erupts nitrocarbonatite lava, which is rich in sodium and potassium carbonates. This unusual lava has a much lower temperature than typical basaltic lava, around 500 degrees Celsius compared to over 1,000 degrees Celsius. The nitrocarbonatite lava is also very fluid and can flow rapidly across the landscape. Because of its composition, the lava is white when it cools, giving Old Donyo Lengai the nickname Mountain of God among the local Maasai people. The phenomenon of volcanic hyperthermals involves periods of rapid global warming triggered by volcanic activity. One such hyperthermal event occurred 56 million years ago and is known as the Paleocene-Eocene thermal maximum. During this time, massive volcanic eruptions released enormous amounts of carbon dioxide and methane into the atmosphere, causing global temperatures to rise by 5 to 8 degrees Celsius over a few thousand years. This event led to significant changes in Earth's climate and ecosystems, including the extinction of many marine and terrestrial species, and the rapid evolution of new species adapted to warmer conditions. Lava tubes are fascinating geological structures associated with basaltic lava flows. These tubes form when the surface of a lava flow cools and solidifies while the molten lava underneath continues to flow. Once the eruption ceases, the remaining molten lava drains away, leaving behind hollow tunnels. Lava tubes can be quite extensive. Some, like the Kazumura Cave on the Big Island of Hawaii, stretch for over 40 miles. These tubes provide unique habitats for specialized plants and animals, and offer spelunkers and scientists opportunities to explore the inner workings of volcanic landscapes. The eruption of Mount St. Helens in Washington state in 1980 was a landmark event in the study of volcanology. Prior to the eruption, the north side of the volcano swelled dramatically due to the injection of magma below the surface. This bulging was a clear warning sign, but the scale of the upcoming eruption was still underestimated. On May 18, 1980, an earthquake triggered a massive landslide, the largest in recorded history, which caused a lateral blast that decimated the surrounding area. The eruption provided scientists with unprecedented data on volcanic processes and the importance of monitoring volcanic activity. Volcanic ash, despite its seemingly innocuous appearance, can have serious health and environmental impacts. When inhaled, volcanic ash can cause respiratory problems and aggravate pre-existing conditions like asthma. The fine particles can also infiltrate buildings, machinery, and water supplies, causing damage and contamination. Additionally, when volcanic ash mixes with water, it can create a substance similar to concrete, which can collapse roofs and clog drainage systems. The long-term exposure to volcanic ash can also affect agriculture, as the ash can alter soil properties and reduce crop yields. Therefore, communities near active volcanoes must have measures in place to mitigate these risks. The concept of volcanic hotspots helps explain the formation of island chains like Hawaii. A hotspot is a plume of hot material that rises from deep within the Earth's mantle to the surface. As the tectonic plate moves over the stationary hotspot, a series of volcanoes forms. Each volcano becomes dormant as it moves away from the hotspot, and a new one forms in its place. This process has created the Hawaiian Islands over millions of years. The current location of the hotspot is under the Big Island of Hawaii, where Kilauea and Mauna Loa are active volcanoes. Volcanoes on other planets and moons provide clues about the geological processes beyond Earth. Mars, for example, is home to the largest volcano in the solar system, Olympus Mons, which stands nearly 13 miles high. Unlike Earth, where tectonic plates are constantly moving, Mars appears to have a static crust, allowing a single volcanic hotspot to build Olympus Mons over a long period. Io, one of Jupiter's moons, is the most volcanically active body in the solar system. Its intense volcanic activity is driven by tidal heating, as Jupiter's gravitational pull causes friction and heat within Io. Volcanoes can create deadly lahars, which are volcanic mud flows composed of water, volcanic ash, and debris. Lahars can be triggered by the melting of snow and ice during an eruption or by heavy rainfall mixing with loose volcanic material. These fast-moving flows can travel great distances from the volcano, burying everything in their path. The eruption of Nevado del Ruiz in Colombia in 1985 caused a lahar that devastated the town of Armero, killing over 20,000 people. Lahars are particularly dangerous because they can occur with little warning and have the consistency of wet concrete, making them incredibly destructive. The interaction between water and magma can lead to a special type of volcanic eruption called a phreatomagmatic eruption. When magma comes into contact with water, either from groundwater or a body of water, the water rapidly heats up and converts to steam, causing a violent explosion. This type of eruption can produce fine ash and fragmented volcanic material. The 1980 eruption of Mount St. Helens included phreatomagmatic activity when the volcano's summit glacier melted and interacted with the rising magma. This interaction amplified the explosiveness of the eruption and contributed to the massive ash column that spread across the United States. Monogenetic volcanic fields are regions where volcanoes erupt only once and then become inactive. These fields are characterized by numerous small, scattered volcanic cones, rather than a single dominant volcano. An example of a monogenetic volcanic field is the San Francisco Volcanic Field in Arizona, which contains over 600 volcanic features. Each of these volcanoes erupted at different times over the past 6 million years. The last known eruption in this field occurred around 930,000 years ago. Studying these fields helps scientists understand the dynamics of volcanic systems and the potential for future eruptions in these areas. The Volcanic Explosivity Index, or VE, is a scale for measuring the size of an explosive volcanic eruption. It ranges from 0 to 8, with each increment representing a tenfold increase in the volume of erupted material. For example, the eruption of Mount St. Helens in 1980 had a VE of 5, while the eruption of Toba around 74,000 years ago had a VE of 8. The VI helps volcanologists compare eruptions and assess their potential impacts on human populations and the environment. Eruptions with a VE of 4 or higher can have significant regional and even global effects. Some volcanic eruptions can produce pyroclastic surges, which are highly mobile, ground-hugging clouds of hot gas, ash, and volcanic debris. These surges move at incredible speeds, often exceeding 100 miles per hour, and can incinerate or suffocate anything in their path. The eruption of Mount Vesuvius in 79 AD produced pyroclastic surges that overwhelmed the cities of Pompeii and Herculaneum. These surges are different from pyroclastic flows in that they contain a higher proportion of gas, making them even more fluid and capable of crossing obstacles like valleys and ridges, posing extreme danger to life and property. Volcanoes can act as natural laboratories for studying extremophiles, organisms that thrive in extreme environments. The high temperatures, acidic conditions, and chemical-rich environments around volcanic vents are home to unique microbes that have adapted to these harsh conditions. For example, the hot springs in Yellowstone National Park, which are heated by the underlying supervolcano, are home to thermophilic bacteria that can withstand temperatures above 70 degrees Celsius. These extremophiles are of great interest to scientists because they offer insights into the limits of life on Earth and the potential for life on other planets with extreme conditions. The impact of volcanic eruptions on aviation has become a significant concern in modern times. Volcanic ash clouds can pose serious threats to aircraft, as the fine particles can damage engines, corrode metal surfaces, and obscure visibility. In 1982, a British Airways flight experienced a near disaster when it flew through an ash cloud from Mount Galunggung in Indonesia. All 4 engines failed, and the aircraft descended rapidly before the crew managed to restart 3 engines and safely land the plane. This incident highlighted the need for improved monitoring and communication to avoid ash clouds, leading to international efforts to enhance aviation safety measures. Volcanoes can influence oceanic environments in various ways. Undersea eruptions can create new habitats for marine life, as was observed with the eruption of the West Mata volcano near Samoa in 2009. The eruption produced pillow lavas and hydrothermal vents, which became colonized by unique species of bacteria, shrimp, and other organisms. Volcanic islands can also affect ocean currents and local climate patterns. For instance, the volcanic island of Tristan da Cunha in the South Atlantic Ocean alters the flow of the surrounding ocean currents, impacting marine biodiversity and fishing patterns in the region. Volcanic tremor is a continuous rhythmic seismic signal associated with the movement of magma and volcanic gases. Unlike the short, sharp jolts of typical earthquakes, volcanic tremors can last from minutes to days. These tremors are often a precursor to volcanic eruptions, providing valuable information for monitoring active volcanoes. For example, the 1977 eruption of Krafla in Iceland was preceded by a noticeable volcanic tremor, allowing for successful prediction and evacuation efforts. Volcanic tremors are detected using seismographs, and their characteristics can help volcanologists understand the internal dynamics of a volcano and assess the likelihood of an impending eruption. Some volcanoes are known for their persistent activity, exhibiting continuous low-level eruptions for extended periods. Stromboli, an island volcano in Italy, is one such example and has been erupting almost continuously for over 2,000 years. Known as the lighthouse of the Mediterranean, Stromboli's consistent eruptions produce spectacular fire fountains and lava flows that can be observed from a safe distance. The ongoing activity at Stromboli provides a unique opportunity for scientists to study the long-term behavior of volcanic systems and gain insights into the processes that drive continuous eruptions. Volcanic gases emitted during eruptions can have far-reaching environmental impacts. Sulfur dioxide is one of the primary gases released and can react with water vapor in the atmosphere to form sulfuric acid aerosols. These aerosols can spread globally and have cooling effects on the Earth's climate by reflecting sunlight away from the surface. The eruption of Mount Pinatubo in 1991 released large amounts of sulfur dioxide, leading to a temporary global temperature decrease of about 1 degree Celsius. These cooling effects can last for several years, influencing weather patterns and potentially offsetting some warming caused by greenhouse gases. The phenomenon known as volcanic winter is another consequence of large eruptions. When a massive amount of volcanic ash and sulfur gases are ejected into the stratosphere, they can significantly reduce the amount of sunlight reaching the Earth's surface. This reduction in solar radiation can lead to cooler temperatures and disruptions in climate patterns. One of the most famous examples is the eruption of the Toba supervolcano approximately 74,000 years ago, which is believed to have caused a volcanic winter lasting several years. Such events can lead to crop failures, food shortages, and significant impacts on human societies. During the eruption of Mount St. Helens in 1980, a phenomenon known as a lateral blast occurred. Unlike most eruptions that send debris vertically, this blast ejected volcanic material sideways. The explosion was so powerful that it leveled forests up to 17 miles away and dramatically reshaped the mountain itself. This event highlighted the unpredictable nature of volcanic eruptions and demonstrated that hazards could extend far beyond just lava flow and ashfall. Volcanic lightning is a rare but fascinating phenomenon that occurs during eruptions. When a volcano erupts, it ejects ash, rock, and gases into the atmosphere. This creates friction between the particles, generating static electricity. The buildup of electrical charges can result in dramatic and powerful lightning strikes within the volcanic ash plume. One of the most famous examples of volcanic lightning occurred during the eruption of the Eyjafjallajökull volcano in Iceland in 2010. The Hawaiian Islands are entirely volcanic in origin, formed over millions of years by the Hawaiian hotspot. As the Pacific tectonic plate moves over the stationary hotspot, magma rises to the surface and creates volcanoes. The island of Hawaii, also known as the Big Island, is home to Kilauea, one of the most active volcanoes on Earth. This ongoing volcanic activity provides scientists with valuable insights into volcanic processes and helps educate the public about the dynamic nature of our planet. Olympus Mons on Mars is the largest volcano in our solar system, standing approximately 13 miles high, almost 3 times the height of Mount Everest. This shield volcano covers an area roughly the size of Arizona. Its immense size is largely due to the lack of plate tectonics on Mars, which allows the volcano to grow much larger than those on Earth. Studying Olympus Mons helps scientists understand volcanic activity beyond our own planet, offering clues about the geological history of Mars. Tephra is a general term for fragments of volcanic rock and ash that are blasted into the air during an eruption. The size of tephra can range from tiny ash particles to large boulders known as volcanic bombs. These materials can travel great distances, with fine ash capable of circumnavigating the globe. Tephra not only poses immediate hazards to health and infrastructure, but can also impact the climate by reflecting sunlight and lowering global temperatures temporarily. Volcanic gases play a critical role in both eruptive and non-eruptive volcanic activity. The most common volcanic gases are water vapor, carbon dioxide, sulfur dioxide, hydrogen sulfide, and various other compounds. These gases can escape quietly through fumaroles or be violently ejected during an eruption. Sulfur dioxide in particular can lead to the formation of acid rain and have long-term impacts on the environment. Understanding the composition and behavior of volcanic gases helps in monitoring and predicting volcanic activity. The Ring of Fire is a major area in the Pacific Ocean basin where a large number of earthquakes and volcanic eruptions occur. Approximately 75% of the world's active and dormant volcanoes are found within this ring. The volcanic activity in this region is largely due to the movements of several tectonic plates colliding, pulling apart, and sliding past each other. The Ring of Fire is a focal point for volcanic research and hazard mitigation efforts, given its impact on densely populated regions. Lahars, or volcanic mudflows, are one of the most deadly volcanic hazards. A lahar is a mixture of volcanic ash, debris, and water that flows down the slopes of a volcano, often at high speeds. These flows can be triggered by heavy rainfall, melting snow and ice, or the eruption itself. The town of Armero in Colombia was devastated by a lahar from the Nevado del Ruiz volcano in 1985, resulting in the deaths of over 20,000 people. This tragedy underscored the need for better volcanic hazard preparedness and early warning systems. Volcanoes have played a significant role in human history and mythology. The ancient Romans believed that the god Vulcan had his forge beneath Mount Etna, and it was his work that caused the frequent eruptions. Similarly, the Hawaiian volcano goddess Pele is said to reside in the Halemaumau crater of Kilauea. These myths often encapsulated the awe and fear that volcanoes inspired, and they served as early attempts to explain the powerful natural forces at play. Such stories continue to influence cultural perspectives on volcanic activity. The island of Santorini in Greece is renowned for its stunning caldera formed by a massive volcanic eruption around 1600 BCE. This eruption, one of the largest in recorded history, ejected an estimated 4 to 5 cubic miles of material and generated tsunamis that affected the surrounding regions. The eruption likely contributed to the decline of the Minoan civilization on the nearby island of Crete. The event has been linked to the legend of Atlantis, demonstrating how volcanic eruptions have shaped both physical landscapes and cultural narratives. Volcanic eruptions can have long-lasting impacts on climate. The eruption of Mount Tambora in Indonesia in 1815 is a prime example. The colossal eruption injected vast amounts of sulfur dioxide into the stratosphere, which then spread globally and reflected sunlight. This led to the year without a summer in 1816, causing crop failures and food shortages in the northern hemisphere. Such volcanic-induced climate anomalies illustrate the far-reaching effects that a single eruption can have on the planet's climate and ecosystems. Volcanic winter is a term used to describe a reduction in global temperatures caused by volcanic ash and droplets of sulfuric acid obscuring the sun. One of the most famous instances of a volcanic winter occurred after the eruption of Krakatoa in 1883. The eruption produced spectacular sunsets due to the particles in the atmosphere, but it also led to a significant drop in global temperatures. Volcanic winters remind us of the interconnectedness of Earth's systems and how events in one region can impact the entire globe. Pele's hair is a type of volcanic glass that forms during the explosive eruptions of basaltic lava. Named after the Hawaiian volcano goddess Pele, these glassy fibers are created when lava is ejected into the air and stretched by the wind into thin hair-like strands. Although fascinating to look at, Pele's hair can be quite hazardous if inhaled or if it comes into contact with skin, causing irritation. This unique volcanic product highlights the diverse and sometimes dangerous materials that can result from volcanic activity. Volcano tourism has become increasingly popular in recent years, with people traveling to witness active volcanoes up close. Destinations like Mount Etna in Italy, Arenal in Costa Rica, and the volcanoes of Hawaii attract numerous visitors each year. While this can boost local economies, it also poses risks to tourists and demands careful management. The eruption of New Zealand's White Island in 2019, which tragically resulted in the loss of lives, underscores the importance of safety and awareness when visiting active volcanic sites. Cryptodome is a term used to describe a bulge formed by the intrusion of viscous magma beneath the surface of a volcano. This can create significant pressure and eventually lead to an explosive eruption. One notable example is the cryptodome that formed in Mount St. Helens prior to its eruption in 1980. The cryptodome's growth caused the north flank of the volcano to become unstable, ultimately resulting in massive landslide and lateral blast. Understanding cryptodome formation is crucial for predicting and mitigating the impacts of volcanic eruptions. Pumice is a type of volcanic rock that forms when magma with a high gas content cools and depressurizes rapidly. The resulting rock is riddled with gas bubbles, making it light enough to float on water. Pumice has various uses, including in construction, where it is used as an abrasive and in lightweight concrete. Fascinatingly, large pumice rafts occasionally form after underwater volcanic eruptions, drifting across oceans and sometimes transporting marine life with them. This unique rock exemplifies the diverse materials and phenomena associated with volcanic activity. Volcanic arcs are chains of volcanoes formed above subducting tectonic plates. These arcs are typically found at convergent plate boundaries where one plate is forced beneath another. The Ring of Fire is a prime example of a volcanic arc system. Volcanic arcs are characterized by explosive eruptions and are often associated with large earthquakes. Their study helps scientists understand the dynamics of plate tectonics and the processes that lead to the formation of volcanoes. The study of volcanic hazards encompasses a broad range of potential dangers, including lava flows, ashfall, pyroclastic flows, and volcanic gases. Volcanologists work to identify, monitor, and mitigate these hazards to protect communities living near volcanoes. Advances in technology such as remote sensing and satellite monitoring have greatly improved our ability to detect early signs of volcanic activity. Despite these advancements, accurately predicting eruptions remains a complex challenge, underscoring the need for continued research and preparedness. Basaltic lava flows are among the most common and least explosive types of volcanic activity. These flows are characterized by their low viscosity, which allows the lava to travel great distances from the vent. The Pahoho and LA are two well-known types of basaltic lava flows. Pahoho flows have a smooth, ropey surface, while AA flows are rough and fragmented. The study of basaltic lava flows provides insights into the behavior of less explosive eruptions and helps inform hazard assessments and mitigation strategies. Volcanic surveillance often involves the use of tiltmeters, which measure the deformation of a volcano's surface over time. As magma accumulates beneath a volcano, it can cause the ground to swell, providing an early warning sign of potential eruptions. Tilt meters are highly sensitive instruments that can detect even minor changes in ground deformation, helping scientists monitor volcanic activity with greater precision. This data is crucial for making informed decisions about evacuation and other safety measures in the event of an impending eruption. Underwater volcanoes, also known as submarine volcanoes, are found on the ocean floor and can form at both divergent and convergent plate boundaries. These volcanoes are often located along mid-ocean ridges where tectonic plates are pulling apart, while most submarine eruptions go unnoticed. They can have significant impacts on marine ecosystems and even create new landforms over time. The study of submarine volcanoes is essential for understanding the full scope of volcanic activity on Earth and the geological processes at work beneath the ocean surface. Volcanic hotspots are locations where magma from deep within the mantle rises to the surface, creating volcanoes. These hotspots are independent of tectonic plate boundaries and can form volcanic chains as plates move over them. The Hawaiian Islands are a classic example of a volcanic chain formed by a hotspot. Hotspots provide valuable insights into mantle processes and the dynamics of Earth's interior, helping scientists piece together the complex puzzle of plate tectonics and volcanism. A pyroclastic surge is a type of fast-moving, ground-hugging flow that results from explosive volcanic eruptions. Unlike pyroclastic flows, which are denser and more confined to valleys, surges are more dilute and can travel over obstacles and across flat terrain. These surges consist of hot gases, ash, and volcanic debris, and can reach speeds of up to 200 miles per hour. The deadly eruption of Mount Pelée in 1902 produced pyroclastic surges that destroyed the town of St. Pierre, killing nearly 30,000 people. Volcanic ash can pose significant hazards to aviation. Ash clouds can extend thousands of miles from the eruption site and reach altitudes that intersect with commercial flight paths. Ingesting volcanic ash can cause jet engines to fail and damage other aircraft systems. The eruption of Eyjafjallajökull in 2010 led to the unprecedented closure of European airspace for several days due to the volcanic ash cloud, disrupting travel for millions of passengers. This event highlighted the importance of monitoring volcanic activity and developing strategies to mitigate its impact on aviation. Volcanic tremors are continuous rhythmic seismic signals associated with the movement of magma beneath a volcano. These tremors can serve as important indicators of impending eruptions, as they often precede explosive activity. By carefully monitoring volcanic tremors along with other geophysical data, scientists can improve their ability to forecast eruptions. The study of volcanic tremors is an essential component of volcanology, providing valuable insights into the internal dynamics of volcanoes and helping to enhance public safety through early warning systems. The lava lakes found within certain volcanic craters are fascinating yet rare phenomena. These lakes are composed of molten lava that remains in a liquid state due to continuous heat from below. One of the most notable examples is the lava lake at Kilauea's Halemaumau crater in Hawaii. Lava lakes offer unique opportunities for scientific study, as they provide direct access to active volcanic processes. However, they also pose significant risks to researchers due to the extreme temperatures and potential for sudden changes in volcanic activity. In volcanic regions, hydrothermal systems are often formed by the interaction of groundwater with magma. These systems can produce various geothermal features, such as hot springs, geysers, and fumaroles. Yellowstone National Park in the United States is home to one of the most extensive hydrothermal systems in the world, with over 10,000 geothermal features. Studying these systems helps scientists understand the subsurface volcanic processes and allows for the development of geothermal energy resources, which can provide clean and sustainable power. The eruption of the Loki fissure in Iceland in 1783 had far-reaching consequences beyond just the local area. The eruption released massive amounts of sulfur dioxide and other gases into the atmosphere, leading to a haze that spread across Europe. This volcanic haze caused widespread crop failures and food shortages, contributing to famine and social unrest. The event is often cited as one of the factors that led to the French Revolution. The Loki eruption serves as a sobering reminder of how volcanic activity can influence human history in profound ways. The Decade volcanoes are a group of 16 volcanoes identified by the International Association of Volcanology and Chemistry of the Earth's interior usually referred to as EFC, as being worthy of particular study due to their history of large destructive eruptions and their proximity to densely populated areas. Examples include Mount Vesuvius in Italy, Mount Rainier in the United States, and Mount Nyiragongo in the Democratic Republic of the Congo. The Decade Volcano Initiative aims to enhance understanding of these high-risk volcanoes and improve disaster preparedness and mitigation efforts. The island of Krakatoa in Indonesia experienced one of the most catastrophic eruptions in recorded history in 1883. The eruption obliterated most of the island, generated massive tsunamis, and caused more than 36,000 fatalities. The explosion was heard as far away as Australia and propelled ash into the atmosphere, affecting global climate for years. This monumental eruption underscored the potential for volcanic events to produce widespread and long-lasting impacts on both human societies and natural systems. Volcanic activity can create unique and sometimes hazardous landforms known as calderas. These large volcanic craters are formed when a magma chamber empties following an eruption, causing the ground above to collapse. The Yellowstone caldera in the United States is one of the most famous examples. These massive structures provide valuable information about the eruptive history and ongoing activity of a volcanic system. However, their potential for future eruptions remains a concern, making them important targets for scientific monitoring and research. The phenomenon of lahar warning systems has gained importance in areas prone to volcanic mudflows. These systems typically utilize a combination of ground-based sensors, remote sensing, and real-time data analysis to detect the onset of lahars. Early warning systems can provide crucial time for evacuating vulnerable communities, thereby reducing the risk of casualties. The implementation of such systems in places like Mount Rainier in the United States has proven effective in enhancing public awareness and readiness for lahar hazards. Eruptions under ice, known as subglacial eruptions, present unique challenges and hazards. When a volcano erupts beneath a glacier, the intense heat melts large amounts of ice, which can lead to catastrophic floods known as jökull. The Grímsvötn volcano in Iceland is one of the most active subglacial volcanoes on Earth. Monitoring subglacial eruptions is particularly challenging due to the difficult conditions and the complex interactions between magma, ice, and water. However, these types of eruptions offer valuable insights into both volcanic and glacial processes. Acidic volcanic lakes are another intriguing and hazardous feature associated with some volcanic systems. These lakes form in volcanic craters and are highly acidic due to the volcanic gases dissolving in the water. The acidity can reach levels similar to battery acid, posing significant risks to both humans and wildlife. One of the most well-known examples is the crater lake at Kawah Ijen in Indonesia, which contains sulfuric acid. Researchers study these lakes to understand their chemistry and potential hazards, as well as their role in volcanic gas emissions. Some volcanoes produce lava fountains, which are impressive jets of molten lava expelled from a volcanic vent. These fountains can reach heights of hundreds to thousands of feet, creating spectacular visual displays. Lava fountains are often associated with Hawaiian-style eruptions, particularly those involving basaltic lava. Mauna Ulu, part of Kilauea in Hawaii, produced continuous lava fountains during its eruption from 1969 to 1971. These events provide scientists with opportunities to study the dynamics of magma movement and eruption mechanics. Mount Tambora in Indonesia erupted in 1815, marking one of the most powerful volcanic events in recorded history. The eruption released such a massive amount of ash and sulfur dioxide into the atmosphere that it caused global temperatures to drop, leading to 1816 being known as the year without a summer. This drastic climate anomaly led to crop failures and food shortages across the northern hemisphere, significantly impacting the livelihoods of millions of people. Kilauea is one of the most active volcanoes on Earth and is located on the Big Island of Hawaii. Its eruption in 1983 marks the beginning of the longest-lasting eruption in recorded history. The event continued for over 3 decades, producing large lava flows that destroyed homes and altered landscapes. The continuous activity made Kilauea a major site for scientific research, contributing significantly to our understanding of volcanic processes. Lake Toba in Indonesia is the site of one of the largest volcanic eruptions in the last 2 million years. Occurring around 74,000 years ago, the eruption expelled approximately 2,800 cubic kilometers of volcanic material. This catastrophic event not only created a massive caldera now filled by Lake Toba, but also caused a severe volcanic winter, which some researchers believe might have dramatically affected human evolution by leading to a population bottleneck. The eruption of Mount Pelée on the Caribbean island of Martinique in 1902 resulted in one of the deadliest volcanic disasters of the 20th century. A pyroclastic flow, a fast-moving current of hot gases and volcanic matter, obliterated the town of Saint-Pierre, killing all but a few of its 30,000 inhabitants. Remarkably, one of the survivors, a prisoner named Ludger Silberis, lived because his stone-walled cell insulated him from the deadly gases and heat. The Deccan Traps in India are one of the largest volcanic features on Earth, consisting of multiple layers of solidified flood basalt. These layers were created by a sequence of colossal eruptions around 66 million years ago. The outpouring of lava and gases is thought to have contributed to the mass extinction event that also saw the end of the dinosaurs. The sheer volume of lava covers 500,000 square kilometers, an area roughly the size of France. Yellowstone National Park in the United States sits atop a supervolcano, one of the few in the world capable of producing an eruption that would significantly alter global climate. The Yellowstone caldera has erupted 3 times in the last 2 million years, with the last major eruption occurring approximately 640,000 years ago. These eruptions were thousands of times more powerful than typical volcanic events, spewing vast amounts of ash and lava over large areas of North America, and could cause widespread devastation if it were to erupt again. The 1980 eruption of Mount St. Helens in the state of Washington was one of the most significant volcanic events in United States history. A massive landslide and lateral blast reduced the elevation of the mountain's summit by over 1,300 feet. The eruption released an amount of energy equivalent to about 24 megatons of TNT, devastating the surrounding area and claiming 57 lives. The eruption also provided valuable insights into lateral blasts, a phenomenon not well understood before this event. The island of Iceland sits atop the mid-Atlantic ridge, where the Eurasian and North American tectonic plates diverge, making it one of the most volcanically active places on Earth. Vatnajökull, one of Europe's largest glaciers, covers several active volcanoes. The eruption of the Grímsvötn volcano in 2011, located beneath this glacier, led to significant flooding due to the melting ice. The volcanic ash cloud disrupted air travel across Europe, affecting hundreds of thousands of passengers. Volcanic lightning, also known as a dirty thunderstorm, occurs when colliding particles of volcanic ash create static electricity within the turbulent environment of an eruption plume. This phenomenon is extremely rare but highly documented, adding an additional sense of awe and danger to volcanic eruptions. The Sakurajima volcano in Japan is particularly famous for this electrifying display, often producing spectacular scenes of lightning bolts slicing through ash clouds, a reminder of nature's immense power and complexity. Mount Vesuvius, near modern-day Naples in Italy, is best known for its eruption in 79 AD, which buried the cities of Pompeii and Herculaneum under a thick carpet of volcanic ash. The catastrophic event preserved these cities in remarkable detail, offering a unique window into ancient Roman life. What makes Vesuvius particularly dangerous is its proximity to heavily populated areas. It's one of the most densely populated volcanic regions in the world, posing a perpetual threat to millions of residents. The volcanic islands of the Azores, located in the North Atlantic Ocean, are an archipelago formed by the movements of the African, Eurasian, and North American tectonic plates. One notable eruption occurred on the island of San Miguel in 1720, when the Fogo volcano blanketed the island in ash and lava. These islands are not only a geological wonder, but also a biodiversity hotspot, home to unique plant and animal species adapted to the volcanic soil and climate. The concept of hotspot volcanism is best exemplified by the Hawaiian Islands. Unlike most volcanoes which occur at tectonic plate boundaries, hotspot volcanoes form in the interior of tectonic plates. The Hawaiian hotspot is currently beneath the Big Island, fueling the activity of Mauna Loa and Kilauea. As the Pacific Plate moves over this stationary hotspot, new islands are periodically formed. This process is responsible for the chain of islands stretching across the Pacific, highlighting the dynamic nature of our planet's lithosphere. New Zealand's Taupo volcano, located in the North Island, produced one of the most violent eruptions in human history around 1800 years ago. Known as the Taupo eruption, it ejected an estimated 100 cubic kilometers of volcanic material, causing catastrophic environmental effects. The eruption's pyroclastic flows devastated nearby regions, and ash fall covered much of the North Island. The event was so massive it reportedly reddened skies as far away as Rome and China, exemplifying the far-reaching impact of major volcanic activities. The Arenal volcano in Costa Rica is one of the most active volcanoes in Central America, having experienced continuous eruptions from 1968 to 2010. The 1968 eruption was particularly destructive, unleashing pyroclastic flows and lava that engulfed several villages, resulting in significant loss of life and property. Today, the volcano and its surrounding region are a popular destination for tourists and scientists alike, offering unique opportunities to study volcanic processes and enjoy geothermal hot springs. Mount Erebus in Antarctica is notable for being the southernmost active volcano on Earth and one of the few with an active lava lake. Discovered by the Ross expedition in 1841, it continues to be a subject of study due to its persistent activity and unique features, such as ice fumaroles, ice towers formed by the interaction of volcanic gases with the cold Antarctic temperatures. The harsh environment complicates research, but Mount Erebus provides invaluable insights into volcanic activity in polar regions. The eruption of Mount Pinatubo in the Philippines in 1991 was one of the largest eruptions of the 20th century. The explosion ejected more than 10 cubic kilometers of material into the atmosphere, leading to global cooling of approximately 1 degree Fahrenheit for a few years due to the large amount of sulfur dioxide released. The eruption forced the evacuation of tens of thousands of people and caused widespread devastation. However, it also provided scientists with critical data that helped improve volcanic prediction and preparedness techniques. The Campi Flegrei caldera near Naples, Italy, is one of the most extensive volcanic features on Earth, encompassing 24 volcanic craters and edifices. The region is noteworthy because it experienced a massive eruption approximately 39,000 years ago, known as the Campanian Ignimbrite eruption. This event released such a significant amount of volcanic material that it is believed to have contributed to the extinction of Neanderthals. Today, the caldera remains active, posing a lingering threat to the densely populated area surrounding it. The 1973 eruption of Eldfell on Heimaey Island in Iceland led to one of the most remarkable human efforts to combat a volcanic event. Lava flows threatened the island's harbor, crucial for the local fishing industry. In a bold and unprecedented move, authorities decided to pump seawater onto the advancing lava to cool and solidify it. This effort was remarkably successful, saving the harbor from being lost to the volcanic activity and allowing the island's inhabitants to eventually return and rebuild their homes. The ancient city of Akrotiri on the Greek island of Santorini was buried under volcanic ash around 1600 BC due to the eruption of Thera, one of the largest volcanic eruptions in recorded history. Remarkably, no human remains have been found at the site, suggesting that the inhabitants had advance warning and evacuated. The preserved ruins offer a snapshot of Minoan civilization, providing archaeologists with invaluable insights. The eruption might have also inspired the legend of Atlantis, demonstrating how volcanoes can shape cultural narratives. Mount Fuji in Japan is a stratovolcano that last erupted in 1707, an event known as the Hoai eruption. It deposited ash as far away as Tokyo, over 60 miles from the volcano. Mount Fuji holds significant cultural importance, symbolizing beauty and strength in Japanese art and literature. Despite its dormancy for over 3 centuries, it remains closely monitored by scientists due to its proximity to populous areas and its potential to disrupt air travel and affect millions of people should it erupt again. The 1990 eruption of Kelut volcano in Indonesia involved a dramatic phenomenon known as a volcanic lake drainage. Kelut has a crater lake that can cause lahars, destructive volcanic mudflows, when an eruption disrupts the lake. In 1990, the lava dome blocked the outlet, causing the lake to overflow and create devastating lahars. This event led to significant advances in hazard mitigation strategies, such as the construction of drainage tunnels to manage the water levels in Kelut's crater lake, thus reducing future risks. The eruption of Mount Mazama around 7,700 years ago led to the formation of Crater Lake in Oregon, one of the deepest lakes in the United States. The caldera left by the eruption eventually filled with water, creating a stunningly clear lake that's famous for its deep blue color. The eruption was so massive it ejected about 50 cubic kilometers of material into the atmosphere. Crater Lake is a popular site for scientific research, providing crucial data on volcanic activity and caldera formation. Mount Ruapehu in New Zealand is one of the most active volcanoes in the world and the largest active volcano in New Zealand. The 1995 and 1996 eruptions caused significant ash fall, disrupted air travel, and led to the temporary closure of ski fields on the mountain. The eruptions also highlighted the dangers of lahars, as the melting snow and ice mixed with volcanic debris. This led to the establishment of a lahar warning system, which has significantly improved disaster preparedness in the region. The 1986 eruption of Mount Nyiragongo in the Democratic Republic of the Congo is noted for its extremely fluid lava, which flows much faster than typical lava. On that occasion, the lava lake at the summit drained in less than 1 hour, producing lava flows that traveled at speeds up to 60 miles per hour. This rapid movement devastated the nearby town of Goma and resulted in over 100 deaths. Mount Nyiragongo's unique lava composition continues to be a focal point for volcanologists studying effusive eruptions. The eruption of Nevado del Ruiz volcano in Colombia in 1985 is one of the deadliest volcanic disasters in history, primarily due to lahars. An initial eruption melted part of the ice cap on the volcano, sending torrents of volcanic mud flows down into the town of Armero, located over 40 miles away. The lahars buried the town, killing more than 20,000 residents, and highlighting the severe hazard posed by ice-capped volcanoes, even when located far from densely populated areas. Papua New Guinea is home to some of the world's most active volcanoes, including Mount Tavavour. The 1994 eruption of Tavavour, along with nearby Vulcan volcano, devastated the town of Rabaul, covering it in ash and forcing the evacuation of tens of thousands of people. The town was buried under several meters of volcanic material, leading to a significant relocation of its population. Despite the destruction, the event provided valuable lessons in emergency management and volcanic monitoring techniques. The eruption of Mount Laki in Iceland in 1783 to 1784 was catastrophic, emitting vast quantities of basaltic lava and poisonous gases such as sulfur dioxide and hydrogen fluoride. This created a toxic haze that spread across Europe, causing widespread crop failures and contributing to an exceptionally harsh winter. The resulting famine in Iceland killed about 1/5 of the population and affected global climate, showcasing how volcanic events can have far-reaching impacts on human societies and environmental conditions. Mauna Kea in Hawaii, although currently dormant, is considered the tallest mountain in the world when measured from its base on the ocean floor to its summit, standing at over 33,000 feet. Unlike its neighboring Mauna Loa and Kilauea, Mauna Kea's eruptions have been less frequent but highly explosive. The summit is home to some of the world's most advanced astronomical observatories. Its geological features offer a unique opportunity to study the processes that shape volcanic islands over millions of years. The 1963 eruption of Mount Agung in Bali, Indonesia is notable for its devastating effects, killing about 1,500 people and destroying numerous villages. The eruption drastically altered local weather patterns, causing heavy rainfall that led to mud flows. Mount Agung is considered a holy mountain in Balinese culture, and its activity had a significant impact on local spiritual practices. Despite its danger, the volcano remains a symbol of reverence and natural beauty for the island's inhabitants. The 1990 eruption of Mount Redoubt in Alaska demonstrated the disruptive power of volcanic ash on air travel. The eruption sent ash clouds up to 60,000 feet into the air, affecting international flight routes. In one incident, a Boeing 747 jet lost all 4 engines after flying through an ash cloud, though the pilots managed to restart them and land safely. This event highlighted the importance of volcanic ash monitoring and led to improved protocols to safeguard aviation. The La Garita caldera in Colorado, USA, is the site of one of the largest volcanic eruptions in Earth's history. About 28 million years ago, the eruption released over 5,000 cubic kilometers of material, enveloping areas as far away as the Midwest in volcanic ash. The eruption was so massive it dwarfs any recorded human activity, showcasing the enormous power of geologic forces. Today, the caldera is a subject of extensive geological study, revealing crucial information about supervolcanoes and their potential impacts. The volcanic eruption that occurred in Mount Tambora in the year 1815 in Indonesia is one of the most powerful eruptions ever recorded in human history. It spewed out so much ash and sulfur dioxide into the atmosphere that it caused a volcanic winter, lowering global temperatures and leading to what is now known as the year without a summer. Crops failed globally due to the resultant climatic changes, leading to massive food shortages and famines in many regions. The island of Montserrat in the Caribbean is known for the Soufriere Hills volcano, which had been dormant for centuries before it erupted in 1995. The eruption devastated the capital city of Plymouth, leading to its abandonment as the city was buried under several feet of ash. The eruption turned Montserrat into a living laboratory for volcanologists, helping them understand the complex behaviors and hazards associated with volcanic eruptions. When Mount Vesuvius erupted in 79 AD, it buried the Roman towns of Pompeii and Herculaneum under volcanic ash and pumice. This sudden and tragic event preserved the towns in a state of suspension, providing an unprecedented glimpse into the daily life of ancient Roman society. Artifacts, buildings, and even the remains of meals were found unchanged, giving historians and archaeologists invaluable insights into the past. The Icelandic volcano Eyjafjallajökull erupted in the year 2010, and while it might not have been the most powerful eruption, its impact on global air travel was immense. The ash cloud from the eruption spread across Europe, causing the largest air traffic shutdown since World War II. More than 100,000 flights were canceled, affecting over 10 million travelers. This event demonstrated how significantly volcanic activity can impact modern infrastructure and daily life. Mount St. Helens in the United States erupted on May 18, 1980, causing the largest landslide in recorded history. The north face of the mountain collapsed, sending a massive avalanche of rock and ice down the mountainside. This eruption provided valuable lessons in volcanic monitoring and disaster preparedness, leading to improved early warning systems and better understanding of the signs leading up to volcanic eruptions. Krakatoa, located in Indonesia, erupted in 1883, in one of the most violent volcanic events in recorded history. The explosion was so loud that it was heard as far away as Australia and the island of Rodrigues near Mauritius, roughly 3,000 miles away. The eruption caused a series of tsunamis, the most devastating of which decimated the coastal regions of Java and Sumatra, killing over 36,000 people. The Deccan Traps in India are one of the largest volcanic features on Earth, consisting of multiple layers of solidified flood basalt that cover around 200,000 square miles. Formed around 66 million years ago, some scientists believe that the volcanic activity of the Deccan Traps was a contributing factor to the mass extinction event that wiped out the dinosaurs. The immense eruptions released significant amounts of volcanic gases and ash, impacting global climate and ecosystems. The Kilauea volcano in Hawaii is one of the most active volcanoes in the world, with continuous eruptions occurring since 1983. Unlike many volcanoes, Kilauea's eruptions are relatively gentle, producing slow-moving lava flows rather than explosive eruptions. This has allowed scientists to study the volcano closely and gain insights into the mechanisms driving volcanic activity. The island of Hawaii itself is essentially a chain of volcanoes, with Kilauea being one of the youngest. Oldoinyo Lengai in Tanzania is a unique volcano because it produces nitrocarbonatite lava, unlike the more common silicate-based lava. Nitrocarbonatite lava is much cooler in temperature, around 540 degrees Celsius, compared to typical basaltic lava, which is over 1,000 degrees Celsius. The lava from Oldoinyo Lengai is highly fluid and can flow easily, resembling dark oil when it erupts. This unusual lava composition makes Oldoinyo Lengai a point of significant interest for volcanologists. Nevado del Ruiz in Colombia erupted in November 1985, causing the Armero tragedy. The eruption melted the glaciers on the volcano's summit, triggering massive lahars or volcanic mudflows that buried the town of Armero, killing over 20,000 people. Despite warnings from volcanologists, many residents were not evacuated in time. This disaster emphasized the crucial need for effective communication and swift action in volcanic hazard management to prevent such tragic losses of life. Mount Pinatubo in the Philippines erupted in 1991 after being dormant for over 600 years. The eruption injected vast quantities of ash and sulfur dioxide into the stratosphere, leading to a significant temporary drop in global temperatures. The eruption also brought about a considerable amount of climate-altering aerosols, affecting weather patterns around the world. The eruption of Mount Pinatubo serves as a stark reminder of how volcanic activity can influence the Earth's climate system. Yellowstone National Park in the United States sits atop a supervolcano that has had 3 massive eruptions in the past 2 million years. These eruptions were so large that they dwarf any eruption in recorded history. The most recent of these eruptions occurred around 640,000 years ago. Should Yellowstone's supervolcano erupt again, it would have catastrophic impacts far beyond the immediate area, affecting global climate and ecosystems. Mauna Loa in Hawaii is the largest shield volcano on Earth by volume and area, towering 13,678 feet above sea level and extending over 56,000 feet from base to summit. Unlike stratovolcanoes, shield volcanoes like Mauna Loa have gentle slopes built by the eruption of low-viscosity basaltic lava that can travel long distances. Mauna Loa's size and frequent eruptions make it an important site for studying volcanic processes and monitoring volcanic activity. Mount Nyiragongo in the Democratic Republic of Congo is notable for its extremely fast-moving lava flows, which can reach speeds of 60 kilometers per hour. The lava from Nyiragongo is unusually fluid, allowing it to travel quickly, and pose significant risks to nearby communities. The 1977 eruption saw lava pouring out of the volcano at extraordinary speeds, killing several hundred people in its path. Continual monitoring is vital to mitigate risks from such rapid and deadly lava flows. The eruption of Novarupta in Alaska in 1912 was the largest volcanic eruption of the 20th century, releasing 30 times more magma than the Mount St. Helens eruption in 1980. The eruption created the Valley of 10,000 Smokes, a pyroclastic flow deposit that spread over 40 square miles. Despite its remoteness, the Novarupta eruption has provided valuable insights into the scale and impact of massive volcanic events and helps researchers understand similar future threats. Laki, a volcanic fissure in Iceland, erupted in 1783 to 1784, releasing vast amounts of sulfur dioxide and fluoride gases. The eruption produced a toxic haze known as the Laki haze, which caused a significant climatic impact, leading to a drop in temperatures across Europe and North America. The resulting famine due to crop failures and livestock death is estimated to have caused the deaths of 6 million people worldwide, making it one of the deadliest eruptions in history. The island of Santorini in Greece, also known as Thera, was the site of a massive volcanic eruption around 1600 BC that is believed to have contributed to the decline of the Minoan civilization. The eruption was one of the largest in recorded history, creating a caldera and causing tsunamis that devastated surrounding regions. The event has been linked to the legend of Atlantis, although there is no definitive evidence to support this connection. The eruption's impacts are still studied today. Anak Krakatau, meaning child of Krakatoa, emerged from the caldera left by the 1883 Krakatoa eruption. This volcanic island appeared in 1927 and has been growing ever since due to continuous volcanic activity. In December 2018, part of Anak Krakatau collapsed into the sea, triggering a deadly tsunami that struck the coastlines of Java and Sumatra. This tragic event highlighted the ongoing risks presented by volcanic islands and the need for vigilant monitoring. Mount Etna in Sicily is one of the most active volcanoes in the world, with historical records of its eruptions dating back to 500 BC. Etna's frequent eruptions have shaped the landscape of eastern Sicily and have been both a source of destruction and a boon for agriculture due to the fertile soils created by volcanic ash. Recent eruptions continue to provide invaluable data for volcanologists and have made Etna a natural laboratory for the study of volcanic activity. The eruption of Mount Pelée on the Caribbean island of Martinique in 1902 is infamous for the destruction of the city of St. Pierre. A pyroclastic flow, a fast-moving current of hot gas and volcanic matter, engulfed the city, killing nearly 30,000 people within minutes. One of the few survivors was a prisoner held in an underground cell, shielded from the lethal heat and gases. This disaster remains one of the deadliest volcanic events of the 20th century. Mount Erebus in Antarctica is the southernmost active volcano on Earth and is known for its persistent lava lake, one of only a few in the world. The volcano constantly emits minor eruptions and lava fountains, making it a unique subject of study in the harsh environment of Antarctica. Researchers at Mount Erebus face extreme conditions, but their work contributes to understanding volcanic phenomena in one of the most remote places on Earth, offering insights applicable to other lava lakes globally. Mount Unzen in Japan was the site of a catastrophic eruption in 1991 that generated a deadly pyroclastic flow, killing 43 people, including scientists who were studying the volcano. The flow traveled at speeds up to 100 kilometers per hour, obliterating everything in its path. The tragedy underscored the dangers faced by volcanologists and the need for comprehensive safety measures when studying active volcanoes. Despite the risks, research at Mount Unzen has advanced the understanding of pyroclastic flows. Lake Toba in Indonesia is a supervolcano with the largest caldera lake on Earth. Formed by a colossal eruption around 74,000 years ago, the Toba event is believed to have caused a volcanic winter, significantly reducing global temperatures. Some theories suggest the eruption led to a dramatic reduction in the human,